Thank you. Hello, everyone. We're super glad to be here again. We have been here like 2 years ago. It was really nice. So we are both from Zurich, actually, so it was not too far for us to come here. We work at Google, and we are basically focusing on defense in depth technologies, and we kind of try to roll out interesting browser features to protect the user if if the primary defense maybe doesn't work so well. This is Michele, I'm Lucas, and yes, we have a pretty interesting agenda today with a lot of very interesting defense in depth techniques. I will start with content security policy. 2 years ago, we had a talk at Area 41 talking about how to break bad CSP. This talk will basically build on top of that, so will not restate all the, the bypasses. I would rather like to focus on how to roll out a strict policy that actually provides some security guarantees, and what we have kind of learned in the last 2-3 years at Google trying to roll out CSP. It's quite an interesting journey. And then Michele will talk about a lot of other very interesting defense in depth techniques. Some of them are not even implemented yet, but are in the speccing phase, but we still believe they are very promising and wanted to share that. So, brief question around the room. Who knows what content security policy is? Awesome, quite some folks, that's very nice. For those who don't know, I will do like a super quick, really quick intro on 1 or 2 slides, but it will be kind of advanced actually. So what is content security policy? It's actually a response header that instructs the browser to kind of restrict what can be loaded in the browser. So the most prominent use case is mitigating cross-site scripting. It's still a very common issue. So that's quite an interesting use case. But as I said, it's a defense in depth mechanism. So you always should fix the underlying bugs, right? You should not only rely on our content security policy to be your first line defense. So you have to take care of input validation and output encoding, since it's not a replacement for secure coding practices. And something that we often see nowadays is that CSP is used to prevent data exfiltration. It's absolutely not suited for that. I'll have a slide at the end of the CSP part explaining this, showing 2 or 3 bypasses for that. Just wanted to highlight that as well. So CSP is around for many years now, and it's an extremely complex specification actually, because they kept adding things. They kind of liked how CSP is delivered to the browser because it's a response header and you can plug in new things very easily with new keywords and new directives. So it actually became quite popular for, kind of unrelated techniques as well. And they basically just use the CSP transport mechanism. So that makes it quite hard to understand if someone says they rolled out a CSP, what do you actually mean with that, right? Because it could be everything from blocking frames to mitigating cross-site scripting to trying to prevent data exfiltration. So I kind of collected the big use cases. There's probably other ones as well. As I said, we'll focus on XSS here. There's also more advanced injection attacks that a CSP can mitigate, which are basically UI based. So there was, for example, a keylogger that was stealing password just written with CSS and CSS selectors. And in theory, you can also use CSP to protect against those, but it's already quite an advanced topic. Then there's completely different things like, forcing HTTPS by upgrading insecure requests or block all mixed content. And then there is, as already mentioned, you can restrict framing, like framing of childs, but also like extreme options prevent who, or more or less define who can frame you under which conditions for, click checking protection mostly. Or if you're serving user content on a sensitive domain, which you never should, right? Then you could set a block all policy to prevent that any JavaScript ever gets executed on a certain response. As I mentioned, we'll focus on the first category here. It's a huge topic actually, and I think it's also the one use case that CSP was originally designed for, and where it's actually kind of the strongest. 2 or 3 years ago, we kind of did a study. We basically took the Google corpus of the internet and tried to get all the CSPs that were set on responses, and it turns out that most of them were whitelist based. I'll mention what that means in a second. And with some generic rules, we could basically automatically bypass 94% of all of these. It's pretty bad, right? Because it basically tells you that all these people who spend like years rolling out CSP actually gain very little from that. So we thought it's actually a pity because the security guarantees in theory are quite interesting, especially of non-spaced CSPs, but they're almost impossible to use without any other help. So we basically introduced strict dynamic, which I'll explain in a second what it means. And with that, we actually were quite successful in rolling out CSP at Google. So there's different types of content security policies, if you want different flavors to protect against cross-site scripting. Whitelist-based are basically in 95% of the cases trivially to bypass. The idea is you have a content security policy here, which gets delivered to the browser. It basically tells the browser, you know, you are allowed to load scripts from the same domain or yep.com. And in this case, yep.com is allowed by the CSP and it loads. If you have a markup injection and an attacker injects a script tag, like a source script or an inline script, the CSP will compare the source with the whitelist and say it's not allowed, so I'm blocking it. And also the inline script is disallowed because there's no unsafe inline in the policy. That's the TLDR, the basic concept of CSP. Unfortunately, this is very broken. There's a research paper we published about that, and people who have been here 2 years ago also have seen all these bypasses. Basically, if you host Angular or have JSONP endpoints anywhere on your whitelists, your CSP is trivially bypassable. So then there's non-spaced CSPs, which are quite interesting concept because basically you don't whitelist all the domains, which is super fragile and hard because whenever you change a path, it will break your site. Instead, in the policy you deliver, you set a random nonce for every response, and scripts that have the same nonce attribute set will be allowed to execute. This is quite nice because you get rid of all the JSONP bypasses, all this kind of stuff, and it reduces the burden of creating a whitelist in the first place. This is also a reason why it was so easy for us to roll it out at Google. So this is what the non-spaced CSP looks like. It just has a nonce here, and these script tags also have the nonce, so they will be allowed to execute. If an attacker injects a script tag, he will not know the random nonce that is set per response, so the browser will deny execution of these scripts, inline scripts and source scripts. So what's the problem with that? In theory, this is quite a cool concept. The problem is if you don't control the entire JavaScript ecosystem of your website, you will probably get problems if you load widgets or other third-party JavaScript. For example, if you load a Twitter widget, it will do like create element script and load child scripts, right? Since these child scripts don't have nonces set, they will be blocked from execution, and there is probably nothing you can do about it because you don't control the code base of the Twitter widget or the +1 widget or Facebook widget or whatever, right? Or add libraries, I don't know. So that's actually a problem. This is why actually no one is using nonce-only CSPs nowadays because they're very hard to roll out, except if you have like maybe small applications. So this is what strict dynamic is for. It basically propagates trust to child scripts. The assumption is if you already have script execution as an, even as an attacker, it's game over anyway, right? So child script execution is not really the security boundary here. So if you have a script with a nonce that is blessed by CSP, child scripts will be allowed to execute. This is very nice because suddenly all the widgets and other code paths that do like, module loading in JavaScript just start working out of the box. And there is some details here. only script creation through the JavaScript DOM APIs will be allowed. Anything that includes a parser like document write or inner HTML will not propagate the trust to child scripts, because these are very common sources of DOM XSS. One problem is here though, if this script source is attacker controlled or user controlled, you basically can bypass a strict dynamic CSP, right? Because if this value is not, trusted, it will execute the attacker code in that scenario. So in general, we can basically classify these nonce-based CSPs into multiple levels with multiple security guarantees and multiple levels of difficulty on how hard they are to deploy. So this is easy to deploy and some security guarantees. Whitelist-based CSPs are basically useless, so I basically didn't mention them. But nonce-based CSP with strict dynamic and unsafe eval are quite easy to deploy, and they give you quite some interesting security guarantees. So for example, there is no whitelist CSP bypasses. They basically mitigate all reflected and stored XSS, which is a pretty strong guarantee. They mitigate XSSs that are based on JavaScript URIs. And especially if you have templating systems that can put the nonces automatically on script tags because they're kind of context aware, they're also quite easy to roll out. And for DOM XSS, many DOM XSSs are mitigated, like inner HTML and this kind of stuff. But DOM XSSs where the root cause of the XSS is attacker-controlled source are not mitigated. If you want to mitigate that as well, you have to go to here. One step in between is eval-free CSPs. Some libraries still use unsafe eval. So if you can, just remove it. I think it's 2018, so hopefully we don't rely on eval too much anymore. Then, of course, if you don't allow unsafe eval, you also get rid of eval-based XSSs. A very interesting category is up here. As I mentioned before, that is like the pure nonce-only CSP. They are kind of hard to roll out because you need to control the full JavaScript ecosystem. We basically have most of our Google CSPs are here. They are quite strong, but for accounts of google.com and other high sensitive domains, we're actually currently trying to get up here, since we're in the lucky position of like controlling basically all the JavaScript we load. But it's still a tremendous task to implement manual nonce propagation, trickle down the nonces to all child scripts. And also yesterday I basically found out that there is a bug in Firefox that if you dynamically create a script tag and set the right nonce to it, and the URL of the script redirects to another script, Firefox blocks that script execution. So luckily we discovered it internally before we rolled it out to users and break the login, right? But yeah, if you follow me on Twitter, I'll probably file the bug later. So that's the interesting things you find out, right? If you're working on this, just like every now and then there's a browser bug and it's like, why is this not working? And it's like, what, the browser? Yeah. So just as an example, this is how a typical policy looks like for every of these levels. If you look at that, the really nice thing is you set the same policy for the entire application for all applications. So you don't have different whitelists and have to fiddle around. As long as the nonce is randomly generated per response, it's fine. This makes it very easy to roll out. And then there's also some interesting new features coming up in CSP3. It's basically to ease the rollout, because sometimes, so basically when you roll out a nonce-based CSP, on-click or in general like event handlers are blocked by the browser because this is like inline scripts, so you have to refactor them out. If you again have some other library and you cannot refactor out an event handler, you can, with this new keyword hash this JavaScript code and manually allow it by putting the hash of this into policy. Of course, this doesn't scale very well. If you have 50 inline event handlers, different ones, your policy will explode, so it's not really a working solution for this kind of case. You will still have to refactor. And the other thing is you have to be careful, because once you hash this part, an attacker could, for example, reuse this snippet in other event handlers in markup injections. And if you hash a lot of these things, you can change some interesting action. You can create some interesting action chains. So use it with care. And there's another one which is, I think, currently only in the proposal state. This is mostly for styles. A style block and a style attribute, they are quite different in the power of, in the expressive power. So a style block can have query selectors, and by that you can, for example, write a CSS keylogger if you have a markup injection. A style attribute is more restricted and cannot do these powerful query selectors. So developers love to use style attributes, right? So in theory, if you want to protect against these UI-based attacks, you could roll out a nonce-based CSP that nonces all the style tags, the inline style tags, and prevents an attacker from injecting new style blocks. And with putting unsafe inline attributes, you could still allow inline styles. It's a bit of a hack, but it kind of raises the bar to some extent, hoping that the CSS spec never introduces too powerful query selectors into the style attributes of elements. So we're not using this, it was just interesting new features which we wanted to share. And yeah, why don't use CSP for data exfiltration? Because basically it's game over once the attacker gains a script execution access. If you can execute scripts, you can basically do like document write a link tag. In the URL, you put whatever data you want to exfiltrate, and then, for example, you click that with JavaScript, right? CSP does not cover navigation, so these kind of things can be easily used to exfiltrate data. So the main goal really is to prevent the script execution in the first place. Once you have that script execution, it's game over, right? And there's other ones like post message, DNS prefetch, window.open. There's a countless of other DOM APIs, or browser APIs that allow you to exfiltrate data, right? Very quick slide about what we have done the last 2 years. Basically, we managed to roll out a nonce-based CSP at Google, and currently we're over 50% of the outgoing traffic having a nonce-based CSP set on the responses, which is something 3 years ago I would not have believed that would be possible, because it is like whitelist-based CSPs were so tedious to roll out and so fragile, and the nonce-based ones are actually really much better in that regard. And of course, we tried to focus initially on the very most sensitive domains like login, Gmail, docs, and gradually we tried to move also to nonce-only CSPs. But for Google, it's usually just a small improvement, since we have very sane JavaScript frameworks that don't do like dynamic script creation based on some DOM snippets, like, I don't know, Bootstrap or jQuery with $HTML and these kind of things. So it's an improvement, but for us, that the strict dynamic-based ones are also quite good. Except if you use Polymer, then it's a really bad framework. Yes, and we also have a couple of tools for rolling out CSP. Some of them we open sourced, like the CSP evaluator. You can basically paste a policy and will tell you in how many ways the policy is broken. If you have anything red, it usually means there's very little benefit of having the policy in the first place. There's also a lot of documentation. I think it might be linked from there as well, on how to roll out a nonce-based CSP with strict dynamic. I think it's CSP with google.com/docs. And internally, unfortunately not publicly available, we also have a CSP frontend to make sense of all the incoming CSP violation reports, because you would be surprised once you roll out a policy how many violation reports you get, although it's actually kind of working, because of antiviruses injecting scripts in every page, malware injecting scripts on, like monetizing all pages the user goes to, or just browser extensions who use bad browser APIs to also inject scripts into pages, right? So you get a lot of noise, and you kind of need to crunch it down, deduplicate it, to be able to find actual breakages. And yeah, this is something Michele mostly worked on, and it's really nice actually. And with that, I'm handing over to SRI, and if you have questions, we have like 10 minutes at the end of the presentation for that. So, yeah, thank you.
Hi, everyone. Great to be here again. So that was the first part is around CSP, what we had to do, how we achieved it, and hopefully to give you a better picture of what's the current state and how you can also take advantage of CSP and make your web properties more secure. Now we're talking about some new and lesser known web mitigation techniques. Some are, let's say, like CSP, a header you can put and on your web properties to add some kind of extra protection, defense in that. And some others are maybe browser settings that we think it's good to know, and they're not very much discussed. So we hope also to spark your curiosity on these new and cutting-edge technologies. Some of these are just in the proposal phase, and I will say for each what is the browser support, if any, or if it's just a draft that is being discussed. So the first one, which is very mature actually, is sub-origin integrity, or SRI. Sorry, sub-resource integrity. There was a slip because I'm going to present something about sub-origins. Sub-resource integrity, or SRI. SRI is basically an attribute you can add to a script tag to basically enforce integrity checks on scripts. Basically, often websites have to load third-party scripts, usually from CDNs, for example, to load jQuery, or, well, common JavaScript libraries. So for performance reasons, for bandwidth reasons, they often load them from an external party. The problem is, if that external party is compromised, this is basically XSS on your site, because an attacker could host their own malicious JavaScript there, and that would be executed in the context of your web page. So SRI basically ensures that that resources hosted on a third-party servers have not been tampered with by doing an integrity check with a hash. So basically, what you have here is a script tag. In this case, from a CDN loading jQuery, you add integrity and you add a SHA-256 hash of the content of the script. How you generate it? Well, for common libraries like jQuery, oftentimes you can basically copy-paste the script tag, which has already the integrity attribute, so there is no work from your side. But sometimes you don't have that ready-made, and so you can go to websites such as srihash.org, or you can also do it manually by looking at a specification. Unfortunately, this is a little bit tricky. You would need to use OpenSSL or, well, some tools to do it. This is base64 encoded of the binary representation of the hash. The browser support for SRI is pretty extensive. Basically, all real browsers support it: Chromium, Firefox, and Safari, and the new versions of Edge. The only one not to support it is old Internet Explorer and Safari on iOS. Yes. Same-site cookies. Same-site cookies are an effective way to mitigate cross-site request forgery vulnerabilities. The idea is to add a flag in cookies, which is called same-site, that allows servers to mitigate the risk of cross-site request forgery. So in a typical cross-site request forgery attack, the problem is that the browser is turned against the user by sending authenticated requests to some kind of vulnerable endpoint on a vulnerable server that has some kind of side effects. So the typical vector is having an auto-submitting form with post that goes to vulnerablebank.com/withdraw and just perform a withdrawal operation. The idea is, what if cookies are not sent if the request initiated from another origin, from another site? So the same site flag in a cookie can have two values, strict and lax. Strict says that cookies are not sent when there is cross-site navigation. This means any kind of navigation that comes from another site would not send cookies, even if you are logged in the vulnerable website. This means that, for example, if the website uses same size strict and you receive a link via email or via Facebook or Google+, you click on it, and you're not authenticated. That's a GET request, and you're not authenticated because the request is the navigation is cross-site. There's also a lax attribute value, which says cookies are not sent when there is cross-site navigation, but only if there is an HTTP method that implies side effects, like post and put and delete. So not GET, basically. This means that the scenario I told before would still have you authenticated, so logged in the site, but basically all the common scenarios, like for XSRF exploitation that usually are post-based or put-based, would not work because the request would not be sent with the cookies. Unfortunately, same-site cookie support is, in browsers, is a little bit more limited, and it's restricted to good browsers. So Chromium and Firefox. We hope to see more support. This is would actually be pretty easy to implement. It would be pretty radical in my understanding way to get rid of XSRF without relying on tokens or orthogonally with tokens. Let's talk about site isolation, CORB, and from origin. So here we are going a little bit in a more of an uncharted territory. Some of these are in a proposal state, and some are being implemented, some are implemented behind the flags, and browser support is also a little bit more scattered. Let's talk more in detail. So site isolation is not something you can put in a header. It's actually a browser setting in Chromium. It ensures that pages from different websites are put into different processes in a strict way. This basically increases security, but also adds some checks blocking the processes from receiving sensitive data from other sites. Without going too much into details, this has been particularly reprioritized. So strict site isolation as a flag has been around for quite some time, but it's been reprioritized in light of the recent speculative attacks like Spectre and Meltdown, while having more strict process boundaries is important. It's important in Chromium, and it's important in other browsers. Other browsers have a different approach in isolating contexts of navigation, so they might benefit more from the technologies I'm about to talk. But this is the Chromium way. So strict site isolation will be turned on by default in next releases of Chromium, but you can enable it right away by going in Chrome flags and enabling strict site isolation. There are very, very small performance hits in some cases, but it's very limited. And the only way where this can break is probably with plugins or in very weird cases. So it's pretty safe to turn on. It's actually the right thing to do to add a new layer of protection against speculative attacks, speculative execution attacks. What is CORB, or cross-origin request blocking? Used to be resource blocking, now it's request blocking. Basically, it's an important part of site isolation that restricts which cross-origin data is sent to a renderer process, limiting the access to such data using speculative attacks like Spectre. So the case here is, for example, an attacker has some kind of markup injection capabilities, does not do outright XSS, but so the attacker does not care about exfiltrating the data in a web context, but has somehow the possibility to exfiltrate it by reading process memory. So here we are not in a web context, we are in a memory corruption context, or no, actually in a let's say binary vulnerability context. So the idea is the attacker has an image tag with some sensitive HTML, The attacker doesn't care that it's not possible to exfiltrate it with web technologies because of, well, same origin policy. But the problem is just having it in the same process space, memory space, can be a problem for these speculative execution attacks. So this prevents that. From origin, which is a proposal right now, it's a header that prevents resources from being loaded and included by non-whitelisted origin. So a website can add from origin header and basically list, so give a whitelist of origins where that are allowed to load the resources. So basically, from origin has been around for some time, and it was thought originally as a inline linking protection mechanism. So, for example, if you have images that you don't want, the bandwidth leeching or hot linking, and basically the browser would not fetch it in the first place. But now it's been revisited together with the others I discussed before in light of attacks such as Spectre. So let's talk about upcoming mitigations. Suborigins are very nice and important mitigation techniques that we would like to see more traction. This is still in a stage of a proposal. Suborigins' whole idea is to make web origins more fine-grained. So web origins are tuples. So web origins are the security boundary of the web. They are a tuple right now defined as scheme, host, and port. The idea is with suborigins, you would add a fourth field called namespace, which is defined in a suborigin header. So the idea is you send a suborigin header with, I don't know, like admin area or sensitive or marketing pages, and you would be able to further isolate your pages as if they were in a separate origin. So an XSS there would not be able to exfiltrate content from the main origin. So the idea is, why are suborigins needed? The idea is, in some cases, it's hard to isolate parts of a website that are more sensitive or they have poorer coding practices by using subdomains or completely separate domains. For example, let's think of WordPress that has the /wp admin, which is almost always on the same domain. It would basically, using, I don't know, WP admin suborigin, that would make it basically segregated, which is a great thing. Let's also think about sensitive functionalities like password reset or marketing pages that sometimes have subpar code quality standards, but maybe for legacy reasons are on the main domain of a company. So adopting suborigins often requires actually some refactoring. Because the origin concept is made more fine-grained. So basically, communication depends on from what to what. Suborigins to suborigin is fine as long as both of the resources send the same suborigin header, because they're considered same origin. Suborigin to the parent origin requires the addition of access control allow suborigin, which is very similar to access control allow origin of course, cross-origin request sharing, resource sharing, sorry. But it is tailored for suborigins. And finally, suborigins to an external origin require, as currently, the use of access control allow origin header. So here I have a small demo to show a Chrome extension that we developed internally. Unfortunately, it's not out yet. If suborigins get more traction, we'll think of open source it. The extension was created by our intern, Elena Ionescu, and allows to prototype what kind of suborigins on your website to see what's the current state and what actions might be needed and what refactoring might be needed. So let's have Google Finance. So Google Finance, for historical reasons, is still mapped on www.google.com, which is the main, well, one of the most sensitive origins on google.com. So we have this extension, suboriginator. We define the target site and we start it. Once it's started, Okay, now it's redirects immediately on to /search, which changed from last time I did this demo. Okay. So this will be a little bit more noisy, but let's just have it work for all www.google.com. I'm not sure it works. But anyway, let's just browse around a little bit, trying to stay on the same origin. So we're looking at our stocks. I can't click here because I will navigate away. I think this might be good enough. Let's display the report. Okay. Okay, this is different from the last time because probably when I put www.google.com, this was larger. But the idea is here the extension populates a report with all these communications that it has found by using Chrome debugging APIs. And in this case, you can see that the page here had requested resources from /async and /search. So basically, these would have to send the same suborigin header because they would need to be on the same suborigins. And also, there are some suborigins to external that require a course header, basically, access control allow origin. You have to think of this report in a little bit of a different way that it is displayed. Actually, this /search is very likely a suborigin to parent origin, unless we want to put also /search in another suborigin. And so in that case, it would be a suborigin to origin. But let's talk about.
Can you show it with about maybe? Like
yes, exactly. Another example, which are some static pages that we have on www.google.com/about. So on this, okay, yes. So here there are some marketing pages and a blog. That is also hosted on www, on /about. So we perform a few actions, like we open videos, we just click around, we open a new one, still on /about, as you can see. There is audio of a monkey. Okay, so here we do display report, yes. And we see that there are some suborigin to suborigin requests, which means on the /about. So basically this means that as long as the resources on /about send the suborigin, whatever, about maybe, these will work out of the box. But there are also some suborigins to external. Basically, these require course header. So usually, suborigins to external do not require refactoring because they already require a course header set on the response. This means that in this case, no refactor is probably needed. Basically, suborigins to origin is usually the case that requires refactoring. Okay, let's continue. Let's stop this and continue. Okay. Origin policy is another mechanism to actually apply a lot of defense in-depth mechanisms, such as content security policy, refer policies, and others, to pin it to an entire origin. So the idea is to maximize coverage by saying, we want these policies to be applied to all the origins, even if we don't explicitly, if we miss something, if we don't explicitly put it in the header of the resources. This complements header-based delivery and actually increases coverage. So sometimes it happens that, for example, error pages or debug handlers are actually sent by a different part of the technology stack, and so we might miss some resources. This makes sure that this does not happen. And this is still a proposal. Feature policy is also a proposal. It allows to selectively enable and disable some web APIs. So basically, you as a webmaster especially in combination with origin policy. I feel that feature policies make sense the most in combination with origin policy. So when pinned to an origin, you can decide, you can say, you can have a manifest that says, I need geolocation API only on /locate, for example, and not anywhere else. So together with the origin policy, you can restrict, you can reduce the attack surface of XSS on the domain by just saying, we just need these web APIs on these endpoints, for example. I think we're also slightly earlier, which is great because we can have more questions, and we really like to receive questions. So any questions you might have. Thank you very much.
Awesome. Hey, thank you very much, guys. That was a really cool, interesting talk. Loving to see the cutting edge stuff. Beautiful.
Thank you. Thank you.
Anyone have any questions at all for these guys? I know it's early morning, but I'm hoping the brains are working already. Anyone have anything? Oh, yes, come on.
Thanks for the talk, guys. How realistic is it that some of these proposals actually end up being adopted across modern browsers? Or is this something that most of the other browser manufacturers are not interested in implementing?
Well, I guess Chrome is usually quite fast in picking them up. Firefox kind of also. And for Safari and Edge, I guess it depends if, how much interest to show in it. Historically, sometimes it took them quite a while to pick up these things, but especially in the light of Spectre and this kind of all the other speculative execution attacks, maybe at least the mitigations in that realm probably get more traction because I guess browser vendors also want to show that they care about security and that they also care about the current security threats, right?
Yes, yeah, exactly. So I would say that it really depends on which one you're talking about. So if you're talking, for example, about the speculative execution one, there is a lot of interest. I'm talking about Corb mostly and from origin, from other browsers like non-Chromium browsers, because it's basically very important for them since they chose to not pursue strict process isolation by site. So it's actually they're actually really wanted. While for others, like for example, suborigins actually are a very complex proposal, required to touch a very delicate component of web security, which is the concept of origin. So there have been some alternative proposals. So for example, some people think that it would be better to actually augment a sandbox attribute in HTML5, in HTML, instead of having a header-based delivery.
Yeah. And I think, for example, Firefox containers, they work on like a somewhat very similar technology than Suborigin, but more or less restricted to the user side, right? It's like not the web administrator who sets the, fine-grained origin. It's more the user that can put different sites into different buckets.
Yeah, I mean, also having some kind of uniform testing framework for all browsers would be great. We're trying really hard to have it. This is because implementation of this mitigation sometimes differs between browsers. And, for example, how origins are implemented across browsers differs. So maybe for some browsers, it's very easy to implement one of these mitigation techniques. For another browser, it might be very hard and require extensive refactoring. So it happened actually in the past. So this might also be something to think about.
Cool. Any other questions? Beautiful.
Hi. So you mentioned that 94% of the people that implemented CSP did it wrong, or it can be bypassed. Do you have any ideas how to fix that, or at least improve that number?
Yes. So as I said, there was basically a talk 2 years ago at Area 41. The TLDR is usually you should not use policies based on CSP whitelists because the design is so fragile, and you will basically almost always end up with whitelist entries that either have like a JSONP endpoints, hosting Angular or other JavaScript frameworks that kind of allow like symbolic execution of code on top of JavaScript, right? So the recommendation really is move away from this type of policy and instead try to use a nonce-based policy, either with strict dynamic or if you can nonce only. If you use strict dynamic, you also have to be careful which kind of JavaScript framework you choose, because some of them introduce bypasses themselves. But the recommendation is basically not use whitelist-based policies. But that was, like, you know, almost everyone uses whitelist-based policies because this is apparently how everyone understood CSP and what they did. And yeah, it would be interesting to do a study again and see if the percentage changed.
Also, in regards of CSP, can you share your thoughts on the script gadget research that your colleagues also did?
Yes, so there is a very cool GitHub page created or mentored by Sebastian Lekis and Kotovic. So they basically collect all the bypasses there for all the frameworks and libraries defined, and they also keep it updated. I think it can be a problem for developers if they use one of these frameworks, right? Luckily at Google, we basically are sticking to a couple of core frameworks, so it's less of a problem for us. I think we had an XSS on a page with strict dynamic that was using Polymer, but this is, for us, it's kind of a known issue because Polymer is really, you know, the boundaries between the DOM and JavaScript, they're so interleaved that CSP as a technology really cannot do much there, right? Same for Angular, but starting from Angular 2, they actually kind of fixed it themselves by having ahead of time, or like basically compiling all the templates ahead of time. And yes, so if you use any of like these like fancy frameworks, I would also recommend to check that page and see if it's there. And if it's there, you might have either to patch some of these frameworks. For example, at Google, we use a internal version of jQuery that basically patches the $HTML call to be compatible with CSP and not introduce this kind of gadgets. Basically, what you have to care for is if you use CSP with nonce and strict dynamic, that whenever like the framework creates a script for you because of templates or whatever, you need to kind of make sure that the source or inner HTML or inner text of a script tag is actually already has a nonce, right? Or you just disable it.
Yeah, and I wanted to add that's very cool research, and especially for the web. I think there's also a talk by the authors in Black Hat this year. In case you're interested, they will present also more research.
Cool. Last chance. Any more questions? Oh, last minute stragglers.
Yeah, there are so many issues with cross-domain calls and all that. As a user, I would like to have a setting in the browser that completely disables all cross-domain calls. Would that also be an option?
I guess it would break every site, but it would be an option, I guess. There are extensions that do that, I think, right? So there's Chrome or Firefox extensions that basically let you specify if you want to allow any cross-domain calls.
Well, having a default source non-policy is not exactly what you asked for, but it's very similar. But also disables JavaScript.
Default source self, right?
You just said cross-site.
Okay. Cross-origin. But I mean,
okay, yeah. Depends what kind of requests you're talking about. But yeah, this would definitely break because that's not how the web works, unfortunately, right? So I think also the CSP whitelist approach didn't work because it was a little bit detached from how the web really worked, which is like a lot of cross-site communication. And you have
changes over time, right?
And it changes over time. So you had this like fluid whitelist that you have to maintain. It was like a burden. So what we are seeing is actually the opposite. Is like the web is very much interconnected, and a lot of requests are made. And actually, they're dependent also on some origins like CDNs, for example, that are actually introduce a single point of failure, and so that's a huge problem.
Cool. If we don't have any more questions, I think we're done then. Thank you very much, gentlemen, once again. Appreciate it.
Thank you.
Just a round of applause for them.